Now. All right, well, sometimes solving by substitution isn't always the best way to go. We've learned to solve by building a table and looking at the data there. We've learned how to solve systems by graphing, and we've learned how to solve using substitution, where you solve for one variable in terms of the other, substitute it back in, and then you have to substitute again to solve for the other one. And substitution is a fine way to solve. But today we're going to take a look at solving the system using the linear combination method. Linear combination method. When I was in school, we called this the elimination method because your first goal is to eliminate one of the variables. But I guess they've decided to change the name to linear combination method, meaning we are going to combine these two equations in a linear fashion. So let me show you what I mean by that. You don't want to blink, and you definitely don't want to wander off in the middle of this, because it's really important to just stick around to see how this works. All right, so you'll notice in the first equation of this system, we have x plus 2y equals 12. And then there's 3x minus 2y equals negative 4. Now, there's a mathematical principle that says that it is possible when you have two equations that if you add this one and this one, they will equal this and this when you add them together. Okay? So if I were to write this out, let me write this out. It's x plus 2y plus 3x minus 2y. That's going to equal 12 plus negative 4. So this is the beginning of linear combination. Okay, now there's a real good reason for why we do linear combination, and I'm about to tell you what that is. Now, maybe you'll notice, maybe you won't, but I'm hoping you will, that when we look at this, you should notice that I've got a positive 2y here and a negative 2y there. So when I'm going to start combining my like terms here. So watch very carefully as I combine my like terms. First of all these parentheses can just drop off because they don't need to be there, because we're adding these two together. So none of their signs will change. If I were subtracting one from the other, then the signs would change inside the parentheses. But since we're not, we don't have to worry about that. So check this out. X plus 3x. I'm combining my like terms. Plus 2y minus 2y. See, the plus 2y and the minus 2y. That equals 12 plus negative 4. Well, let's see, 12 plus negative 4 is 8. That's the same thing as 12 minus 4. Now, when I combine my like terms, what you can see here is my x plus 3x, that becomes 4x. And when I combine positive 2y and negative 2y, those are opposites, right? They cancel each other out and become 0. So they just disappear. So 4x equals 8. Okay, now go back again, make sure. See, I'm combining positive 2y and negative 2y. When you combine those, positive 2 plus negative 2, that makes 0. And 0 means it's not there, so we don't even need it. So now we have 4x equals 8. Well, with that, all I have to do is divide both sides by 4. And I end up with x equals 2. So now I have solved for x. I know what x is. And so I can go back into one of my original equations, and or both of them for that matter, and I can solve for y. So I'm going to take my 2, which is my x, and put it back into my first equation. Okay, so take this equation right here, and I'm going to say x is 2 plus 2y equals 12. All right, well, of course, I'll subtract 2 from both sides because I'm trying to get y by itself. Those cancel out. I get 2y equals 12 minus 2, which is 10. And then I divide both sides by 2. Those 2 cancel each other out. And I get y equals 10 divided by 2, which is 5. So y equals 5. Now, does that work out the same for the second equation? Should it work out the same for this equation right here? 3x minus 2y equals negative 4. Well, just for fun, let's make sure. So 3 times x, which is 2, right? 3 times 2 minus 2y equals negative 4. If I've done this right, I had better come up with y equals 5. So let's see if I did. 3 times 2 is 6 minus 2y equals negative 4. I need to subtract 6 from both sides. 6 minus 6, that's 0. So I get negative 2y equals negative 4 minus 6 is negative 10. Divide both sides by negative 2. And I get, those cancel each other out there. Y equals negative 10 divided by negative 2. Yeah, well, that's positive 5. So I get y equals 5 for both of those. So I'm fairly certain that at this point, I know what my solution is. It would be the ordered pair 2, 5. And if I wanted to be absolutely certain that that was my solution, I would take those values for x and y from my ordered pair, put them back into my original equations up here in the top, and make sure that those equations were true. Okay, now that is the linear combination method. The reason I think that they called it the elimination method is because you'll notice when I first started out here, what I did is I eliminated my y variable and coefficient because they canceled each other out. 2 and negative 2 cancel each other out. They're gone. And I was left with just my x variable to solve for. So that's pretty sweet. Okay. Now, there's a property of equality that allows us to do this. And that's question number 2. What property of equality allows you to combine two equations into one? So it's the addition property of equality. And let me write that out for you. It's kind of a weird little deal. And it goes like this. If A equals B and C equals D, then A plus C will be equal to B plus D. Okay, now that's kind of a weird deal, but this was our first equation where we had the stuff that was added on this side equaling this amount, and that was what the 12. And then we had the second equation where we were adding the coefficients of x and y here equaling the negative 4. Well, so we were able to add those two equations together, or those two expressions that were on the left side together, and we were able to add the two sums together. So if that was the case, like, for example, let me erase all this stuff that I've drawn around this thing here and relabel it so it makes sense in what I'm talking about. So x plus 2y would be like A, and the 12 is our B. And 3 minus 2y is C, and the negative 4 is D. And so what we did is we took A plus C, these two, and added them together over here, A plus C, equaling B plus D over here. And that's just, it is what it is. It's the addition property of equality. And it's kind of like if you look at it from a balance scale sort of perspective. You know, if you've ever seen a balance scale, okay, so you've got these two things and your equal sign is in between, right? That's your balance. Well, if you've got an expression over here equaling some number over here, well, then we add another equation or expression over here, then we would add that other sum over here, and it would still remain balanced. So we can add these two together and add these two together, and it would still remain balanced. All right? If that makes sense. I hope it does. I don't see any question marks in the chat, so I'm assuming that we're doing okay so far. All right? So now that takes us to question number 3, and we may have time to finish it before I run out of time, but we may not. But let's look at this system of equations right here. All right, we have 4x plus 5y equals 22, and we have 4x plus 3y equals 18. Now, here's the problem with these two equations. We can't add these two things together. Because if we do, now another easy way to do this is if you make sure, you'll notice that our x's are lined up nicely here. Our y values, our y variables, and their coefficients are lined up nicely. And furthermore, so are our sums. That's nice because when we look at these, we can actually, if we're going to combine them, we can just add like this. Let me show you. 4x plus 5y equals 22, and 4x plus 3y equals 18. Nope, not 11. 18 equals 18. Now, we can let's just add those, right? And we can, because we're adding these two expressions together. But when we add 4x plus 4x, we get 8x. When we add 5y plus 3y, we get 8y. And when we add 22 plus 18, well, we get 10. Here we get 40. But the problem is, you'll notice one of our variables didn't disappear. You know, it wasn't eliminated, and that creates a problem. Now, I'm going to show you a way that we can solve that problem. So check this out. Now I'm going to go back and erase this stuff here. All right. So why don't adding the two equations work? Well, one variable is not eliminated. Okay. And that's the whole goal. One variable wasn't eliminated. Okay. There we go. Now, here's something that we can do to fix that problem. I'm going to erase what I've got here. Whoop, I thought I was. Okay. Now, instead of just adding them, what we can do first is I'm going to have to multiply one of these expressions. It doesn't make any difference which one. I'm going to multiply by a -1 on both sides of my equal sign. And when I do that, what I end up with now, I'm going to rewrite this whole thing. I get 4x plus 5y equals 22. And then when I multiply -1 through everything, I get -4x minus 3y equals -18. And we'll continue from there tomorrow. You won't have any math homework today, so that's cool.